All right, here we go. So what we're doing here today, guys, some of this you already know, some of this you don't know. So you already know that secant x is the reciprocal, that secant x is the reciprocal cosine. So that's where we got this rule right here. Now, conversely, from that rule, if secant x is 1 over cosine, then we know that cosine x is 1 over secant x because they're reciprocals of each other. Does that make sense? Okay. Same thing with the cosecant x, guys. If cosecant is 1 over sine, then sine x must be 1 over, cosecant x, because they're reciprocals of each other. And then cotangent and tangent are reciprocals of each other as well. So if cotangent is 1 over tan, then tangent is 1 over cotangent. Yay or nay? Nothing crazy, right? All right, now remember, guys, so let me exaggerate quadrant 1 right here. And I'm just going to make it kind of not too extreme. This is some coordinate x comma y. And if I draw a reference triangle, then the horizontal displacement is x. And my vertical displacement here is y. And the hypotenuse is 1. Nothing crazy, right? If I write SOHCAHTOA, then sine is opposite over hypotenuse. Here's my angle, theta. Opposite y, hypotenuse 1. So sine of that angle is y over 1, which is just y. Do you guys see what we did there? Cosine is adjacent over hypotenuse. So cosine of that angle is x over 1, which is just x. Now, remember, you guys told me when we were doing the unit circle, I'm going to write tan theta instead of tan x here, that tan was y over x. Well, we replace what y is. See how y is sine theta and x is cosine theta. Then you get sine theta over cosine theta. So you can say that tan theta is equal to sine theta over cosine theta. In this case, my argument is an x, but I just don't want you to confuse the argument with horizontal displacement. So maybe I should have written everything in terms of theta instead of, okay. And then cotangent is x over y, so cosine over sine. Are we okay? Usually, okay, let's just do this example, guys, real quick. This one's pretty straightforward. Usually when you read this, sine x, cotangent x into cosine x, you can use arrows. We do got to be careful with the arrows, but what they're saying is sine x, cotangent x, and I want to transform this into just cosine x. So what they're saying is that the left side equals the right side. I am going to get it to the equal sign, but I'm going to do it in steps. So step 1, focus on the left. I'm going to write sine x. And instead of writing cotangent x, that sine x is that sine x, I'm going to write what over what? Perfect. Cosine x over sine x. And when I do that, what is going to cancel out? Heck yeah, the sine x is canceled out, and look what you get. Cosine x. So there it is. It works. And then you do 3 little dots in a triangle. That stands for therefore. That stands for, quote unquote, therefore. And then you just say, therefore, sine x cotangent x does in fact equal cosine x, check mark. How do you feel? Not bad, right? That's it. You're done. You know all of it now. Well, kind of. How do we feel? All right. Draw the first quadrant of the unit circle. I'm going to draw it big. There it is. I'm going to extend from the origin. I'm going to draw a reference triangle. That is some x comma y, just like we did before. My reference triangle. Here's my angle. I'm going to call the horizontal displacement x and the vertical displacement y and the hypotenuse 1. Is everyone okay so far? Okay. Again, I'm going to write SOHCAHTOA. And let's see, what am I going to do first? I guess I'll write this first. All right, so sine of this angle, just like before, sine is opposite over hypotenuse, so sine is y, or sine theta is y. Cosine is adjacent over hypotenuse, so x divided by 1, so cosine is x. And those are the only two that I want right now at the moment. Are we still okay, guys? If I look at this right triangle there, I'm going to do Pythagorean theorem. You'll see why we're doing that. So if I do Pythagorean theorem to make a relationship between x, y, and 1, I'm going to write x squared plus y squared equals 1. Are you guys okay so far? All right, I'm going to do a substitution. What is x? Yeah, not everyone at the same time. What is x? Cosine theta. What is y? So I'm going to write this. I'm going to substitute parenthesis cosine theta, close it squared, plus parenthesis sine theta, close it squared, equals 1. You're not going to see it written that way. Most of the time, I'm going to put a semicolon. Most of the time, it's going to be written like this. Cosine with a square on the s, theta, plus sine with a square on the n, theta, equals 1. What that means, and I'll do a side note over here. What that means, cosine theta with the whole thing squared means cosine squared theta. That's all it means. So do not do this. A lot of students do this. They write cosine theta squared. Guess what's squared when you do that? The theta. So it's not. So make sure that is that. See? So make sure that you know that. Put a slash through it. So yeah, cool. All right. Put a bullet, and you're going to write, this is my first one, cosine squared plus sine squared equals 1. That's our first. This is called a Pythagorean identity. And relax, I'm going to show you guys a nice way. Well, I wouldn't say memorize it, but you're going to know it forever, I hope. Okay, you guys ready? So tonight, when you go talk to your boy or your girl, we don't judge here, however you roll, you're going to tell them, you're going to go, hey, babe, I'm cosine squared, and you're sine squared, and together we are 1. And if they don't get it, dump them and upgrade yourselves. No, don't. Just teach them. So say it again. Cosine squared plus sine squared equals 1. So say it. Cosine squared plus sine squared equals 1. So when Valentine's comes around, write a poem. You're cosine squared, I'm sine squared, and together we're 1. I've also seen rings. I've seen rings where one ring says cosine squared, if you Google it, and the other ring says sine squared, and your significant other wears that ring, and you wear the other ring, and guess what? Together you guys are? Yeah, isn't that cute? Now, here's the extreme. If you want, this is a true story. His name is Brian Passwater. He's actually my boss when it comes to College Board, because during the summer I teach, other teachers how to teach this stuff, and he's like the head of the teachers. So anyways, he has cosine squared in his wrist, and his wife has sine squared on her wrist. And I guess that's you want to go get tattoos. I wouldn't recommend it, but there it is. He has cosine squared, his wife has sine squared, and the couple goes, together they're 1. So cool, right? Okay. Yeah. All right. From this, guys, here comes the algebra. It's the algebra that's going to trip you guys up. From cosine squared plus sine squared equals 1, you get 2 expressions, I guess. If you move the cosine squared to the other side, then you get that sine squared is equal to 1 minus cosine squared. And here's the other expression. If I leave the cosine squared alone and I move the sine squared to the other side, bless you, you get that cosine squared equals 1 minus sine squared. So all 3 of those are different expressions that you may see. And they're all relevant. Cool or not cool? Okay, I'm going to take a different color. And I'm going to start with the first bullet that I have here again. So I'm going to write cosine squared theta plus sine squared theta equals 1. I'm going to divide all 3 of my terms by cosine squared. So I divide this by cosine squared. Divide that one by cosine squared. What's cosine squared divided by cosine squared? 1, right? Oh, let's say it again. Yeah. When cosine squared divided by cosine squared is 1. See, you have the same thing on the top, same thing on the bottom. Sine squared over cosine squared, that's going to be what? Yeah, tan, but put a what on it? A squared, because they're both squared, so tan squared. Do you see what we're doing? Come on in. Can you open up the door? What is 1 over cosine squared? What's 1 over cosine? Secant, but because I have a square in the bottom, what am I going to write? Secant squared. That is your second bullet. So write second bullet and write 1 plus tan squared theta equals secant squared theta. Now, just like before, from this one, you can get other expressions. What can you get? If you move the tan squared to the other side, you can get 1 equals secant squared theta minus tan squared theta. If you move the 1 to the other side, you get tan squared theta equals secant squared theta minus 1. And I guess if you want, if you interchange the secant squared and the tan squared, because this does happen, you can also get 1 minus secant squared theta equals negative tan squared theta. Do you guys see all those 3 different ones that we can grab? Yeah, I guess you could have also said the same in the top. Cosine squared minus 1 equals negative sine squared, but I didn't put it in there because you guys can figure it out. How do we feel? All right, I'm going to change my color again. I'm going to go to purple. And I'm going to start with the red one again. And I'm going to go, where do I got space? Right here. Cosine squared theta plus sine squared theta equals 1. And instead of dividing everything by cosine squared, I'm going to divide everything by sine squared. When you do that, what's cosine squared over sine squared? Oops, it's not tan. It is cotangent. Put a what on it? Squared, because both of them are squared. Plus sine squared over sine squared is, not everyone at the same time, 1. And then 1 over sine squared, cosecant. YouTube probably doesn't even think I have a class. YouTube probably thinks I'm just talking to myself, because I don't know if they can hear you guys. I swear, YouTube, there's a class in front of me. Okay. Do we understand that, guys? Are we cool? Yeah. Okay. So here we go. I come over here. I put a third bullet, and I'm going to write that. Cotangent squared theta plus 1 equals cosecant squared theta. And from that one, just like before, you can get different ones. From that one, you can get, if you move the 1 to the other side, you get cotangent squared theta equals cosecant squared theta minus 1. I guess, let's see, I'm going to move the cotangent squared. So 1 equals cosecant squared theta minus cotangent squared theta. And I guess I'll leave it right there. How do we feel, guys? Okay, let's go to the next page. Oh, all right. Yeah, math in the afternoon it's tough, guys. It's tough. Do you guys still have energy? Oh, you never had energy, period? Not even in the mornings? All right. Can you see those? Oh, okay. Is that it? Okay. All right, here we go. It says transform cosine squared minus sine squared into 1 minus 2 sine squared. Okay, so here we go. I'm going to go cosine squared x minus sine squared x. And I want to transform that into 1 minus 2 sine squared x. Here's how we're going to do it. Do you see any cosine squares on the right-hand side? So you're probably going to do some type of substitution with that cosine squared. So I'm going to write side note, SN is side note. And the only formula we know, well, I guess we know 3, but we know, I call this the Valentine's formula. Don't call it the Valentine's formula when you get to the university, but I call that one the Valentine's formula. Well, I guess you can call it that. And when the professor, he or she asks, what's the Valentine's formula? Like, professor, cosine squared plus sine squared equals 1. Your cosine squared is for the sine squared. Valentine's formula. Anyways, so here we go. So that's all I know. I know the Valentine's formula, which is the technical name is Pythagorean identity. So cosine squared x plus sine squared x equals 1. So we got that down. My next move, well, I need to find something to substitute for that guy. So I'm going to get cosine squared x by itself, and I'll move the sine squared to the right. So I'm going to write cosine squared x equals 1 minus sine squared x. So here we go. Parenthesis, and I'm going to insert that. 1 minus sine squared x, close it, minus, that minus is that minus, sine squared x. We're still okay? Okay. There's nothing in front of this. Sometimes there will be. That's why I put parentheses. Sometimes there will be, but there's nothing in front of it. So I can just drop the parentheses. 1 minus sine squared x minus sine squared x. How many sine squared x's do you see? So we can combine like terms. 1 minus 2 sine squared x. Is that what I wanted? Yeah, there it is, check mark. So I'm going to put 3 little dots in a triangle. Therefore, this expression right here, cosine squared x minus sine squared x equals 1 minus 2 sine squared x. Kind of cool, right? If you're in decathlon, this is going to help this year. Do we have any decathlon members here? Yeah, we do. We got Miss Tolene. All right, let's go to the next one. Are we having fun? Are you not entertained? Okay. Such a quiet class. First period is like all rowdy, but you guys are just like, eh. Are you guys tired? Well, don't get tired. We're doing math. Okay. Sorry, guys. All right. You guys ready? Hello, parents. If you guys are having dinner and listening to this, do any of you guys play this in the background while you're eating dinner? Oh, well, I recommend you play it in the background. Okay. Here we go. So it says, prove algebraically that 1 plus cosine x times 1 minus cosine x is, in fact, sine squared is an identity. You guys ready? All right. Start by writing this guy. 1 plus cosine x times 1 minus cosine x. Are we still okay? All right. I prefer that you see that that's, well, okay, we're not there yet, so let's just start. Okay, I'm just going to distribute it, guys. I'm just going to multiply. What is 1 times 1? 1. So write 1. What is 1 times a negative cosine x? Negative cosine x, so write minus cosine x. I'm done with that 1. Go to the next one. What is cosine x times 1? Plus cosine x. What is cosine x times a negative cosine x? Negative cosine squared x. Put the squared after the s, or put cosine x in parentheses with a square on the outside. You always got to have an argument. Are we still okay? All right. What happens to these two right here? They cancel out. The better word is zero out, but cancel out is fine. 1, so they zero out. So bam. And you get 1 minus cosine squared x. Really, that's the difference of squares, but let's not go there. Side note. Again, I'm going to write cosine squared x plus sine squared x equals 1. And I'm going to do things a little differently than last time. Let's see. You see how all this, when I say last time, I'm talking about this morning, first period. So with first period, okay, I'll show you what I did. Don't write this down. With first period, I moved this cosine squared to the right, and then we had the identity sine squared equals 1 minus cosine squared, and then we did that substitution. Or 1 minus cosine squared is sine squared. But with us, you see how this equals 1 already? So I can insert all this for 1. Do you guys see that? So I'm going to write equals, parenthesis, and I'm going to write cosine squared x plus sine squared x, close it, minus cosine squared x. There's nothing in front of the parentheses. If there was a negative, you would have distributed that. So you can just drop it, equals cosine squared x plus sine squared x minus cosine squared x. What's going to cancel? or what's, I just said don't say cancel, right? What's going to zero out? Yeah, the cosine squares. What are you left with? Isn't that what they wanted me to have? There it is. Three little dots in a triangle. I see you, Pearson. Don't worry. So 1 plus cosine x times 1 minus cosine x is, in fact, sine squared x. What's up, Pearson? Yeah, you could have done that too. You could have moved the cosine squared over and then would have said, oh, 1 minus cosine squared is just this sine. You could have done that. That's what I did with the third period. Yeah, you see how that equals 1? I just put that in for 1. Cosine squared plus sine squared is 1. Minus cosine squared, which is that one. Cosine squared. It doesn't matter how you go, you're going to get it right. It doesn't matter how you go, you're going to get it right. So what Pearsall said, Pearsall was like, couldn't I have just moved on your side note? Couldn't I have just moved this cosine squared to the right? And then I would have had sine squared x equals 1 minus cosine squared x. And then you see that you have 1 minus cosine squared x, and you can just infer, because you have 1 minus cosine squared x equals sine squared, you could just say that's just sine squared. Yeah, you could have done that too. Just link them. Link them. Cool or not cool? Cool. All right. I think we're good, guys. Let's go to the next one. Isn't this cool stuff? Don't worry. Next year we'll have calculus AP in the morning. And in the morning, it's a lot more fun than in the afternoon. Because in the afternoon, you guys have already done all this work. And some of you probably fell asleep at 2 in the morning. So right now, this is probably the time. Who takes naps during the weekend around this time? Yeah, me too. Every time. Every Sunday. All the time. Like clockwork. Plus, what do lions do once they finish eating? They take a nap. You guys, after lunch, what do you do after lunch? That's why, well, the class that's hard, in my opinion, I don't know, it's just me. When I was in high school, when I was y'all's age, the hardest class to be in was immediately after lunch, and I never knew why. And it doesn't matter what class it was. It could be the most entertaining teacher. I wanted to always fall asleep after lunch, and it's because we're just animals, right? After you eat, you probably just go to sleep. I don't know. Talk to Miss Vasquez, see if she knows about biology. If there's any truth to after you eat, you want to go to sleep or something, or Google it or something. See what it says. All right, you guys ready for this one? Prove algebraically that cotangent A plus tangent A equals cosecant A secant A is an identity. Okay, I'm going to focus on the left. So I'm going to write cotangent A. If you want to put a parenthesis on the A because that's your argument, that's fine. Tangent of A. And I want to get that to look like this. Okay, so your first move, make cotangent and tangent in terms of sine and cosine. Cotangent is what over what? Which one is it? No, not squared. Just cosine A. You got to keep the argument over sine A. That's cotangent. Plus, and then what is tangent? Sine A over cosine A. Get up to there. Are we okay so far? Okay. When you were in 5th grade or 4th grade, I don't know what grade you start learning fractions, but maybe it's even smaller than that. How do you add two fractions? Common denominator. So I have a sine A on the left term. I have a cosine A on the right term. Were you guys going to say cross multiply? That's a hack. Be careful. So I'm going to take this one right here, and I'm going to multiply this one by sine A over sine A. That's just 1, so you're not changing anything. And I'm going to multiply this term right here by cosine A over cosine A. Do you guys see what we did? Or no? No? Okay. I have a sine A in the bottom of this. I have a cosine A in the denominator of this. If I multiply this one by cosine over cosine and multiply this by sine over sine, I'm going to have a common denominator. Sine A cosine A, sine A cosine A. I'm writing the sine A first because I see cosecant there. So here's what I have, guys. Cosine squared, oh, how did it do that? Cosine squared A over sine A cosine A plus sine squared A over sine A cosine A. my denominator is the same, yeah, I can just write one fraction. Cosine squared A plus sine squared A all over sine A cosine A. The bottom is the product. The top is a sum. Nothing cancels. Are we still okay? Okay. Next, what do I notice about the numerator? Cosine squared plus sine squared. It's the Valentine's formula, which equals what? 1. Not 1. 1. 1 over sine A cosine A. Are we still okay? All right, Chav, that's not cosecant A secant A. Yes, it is. Rewrite this 1 over sine A. Rewrite it like this. 1 over sine A times 1 over cosine A. See, that's 1 over sine A cosine A. So 1 over sine A, that's the same thing as cosecant A. And 1 over cosine A, that's the same thing as secant A. There it is. So, 3 little dots in a triangle. Cotangent A plus tangent A does in fact equal cosecant A, secant A. One more, una más. Sorry guys, that's not my best smiley, but it was okay. He looks a little silly. Are y'all ready? I wish I had pyrotechnics. I wish I could push a button. I'll get some lasers. That will have to work. All right, before we can do this, do you guys remember the word conjugate? No? So if you have something like, do you guys remember? So this is a side note. Side note. So when you have something like 1 plus 3i, when in your Algebra 2 days, and Ms. Gonzalez told you, what's the conjugate of that? You wrote 1 minus 3i. Do you guys remember that? Take a guess. 2 plus 3 cosine theta. What's the conjugate of that? 2 minus 3 cosine theta. Yeah, it's the opposite. It comes from somewhere. It comes from like, if you have a plus b, the conjugate of that is a minus b. And notice that that's going to give you a squared minus b squared, if you were to follow that out. So that's really why it works. Let me go ahead and show you, because some of you guys are just looking at me like, what? A times a, that's a squared. A times negative b minus ab. B times a plus ab. B times negative b minus b squared. See how the middle term just zero out? And maybe you already know this. Maybe you're like, child, that's the whole thing of difference of squares. Difference of squares is a plus b, a minus b. Really, that's what's going to help us out. So here we go. It says, so this was all just side note. Side note. So it says, what does it say? It says, prove algebraically that 1 minus cosine b, so I'll run it right here, 1 minus cosine b over sine b is in fact sine b over 1 plus cosine b. All right, there's no squares anywhere. So what is making this difficult? The numerator. The numerator is making it difficult. Do you guys see that? So because the numerator is making it difficult, we're going to multiply by the conjugate of 1 minus cosine b. Now, I want to multiply by 1. Don't be a robot, because sometimes you guys are really good, and I don't understand. I think that you know what you're doing, but when I say, why did you do that? Like, I don't know, Chop. I'm looking at the notes. That's what you're doing here. You're multiplying by 1 plus cosine b over 1 plus cosine b. Chop, why are you doing that? Because when I multiply like this, guys, this is like the difference of squares. I'm going to have 1 minus cosine squared b, which is what I want. 1 and 2. 1 plus cosine b over 1 plus cosine b, that's just 1. Right? Because I have the same thing in the numerator, the same thing in the denominator. So anytime you multiply anything by 1, it's just itself. So don't be a robot. So that is going to give you, what is that going to give you? Like I said, guys, the numerator is just going to give you the difference of squares, 1 minus cosine squared. But if you don't see that, look, Put parentheses on them. 1 times 1, that's a 1. 1 times positive cosine b, that's a positive cosine b. Cosine b times 1 times the cosine b times 1, that's a minus cosine b. And then cosine b negative times a positive cosine b, that's a minus cosine squared b. Do you guys see that? So the middle terms zero out. See? And then on the bottom, don't even distribute them. Okay, so here's what I have. Equals, here's my next line. I just wanted to go to this. It's okay if you just go right to this next time. 1 minus cosine squared b, as long as you know what you're doing, over sine b, parenthesis, 1 plus cosine b. We're okay. We just did this part right here a little earlier. At least I think I did. Well, kind of. All right, look over here on page 2. 1 minus cosine squared is equivalent to sine squared. Do you guys see that? So I come back and I'm going to go a little side note just so I can let the reader know. 1 minus cosine squared b is equivalent to sine squared b. And that's what I'm going to substitute right there. So I'm going to write this and go like that. And here we go. Sine squared b over sine b, parenthesis, 1 plus cosine b. So catch up. I hope you have your fries. You know, because ketchup. Oh, tough crowd. Tough crowd. Yeah, thank you, miss. I'm going to do stand-up comedy one night, but if I get a crowd like this, I don't know. All right. Law of exponents. Well, miss, are my jokes not entertaining? No, I sit down and got it. Oh, okay. That's the same thing as sine b times sine b, guys. How many can I cancel out? I have a sine b in the bottom, and it's a product on the bottom, and I'm dividing. So inverse operations, I can cancel. How many can I cancel? One of them. So we can cancel, bam, bam. Well, that's the same thing as canceling one of those like that. So look what I have left. I have 1 sine b in the top, over, and in the bottom I have 1 plus cosine b. Is that what I wanted? Yeah, that's exactly what I wanted. So I'm going to write the word so, and then let me zoom out so I can see what I initially started with. 3 little dots and a triangle. 1 minus cosine b over sine b is in fact equal to sine b over 1 plus cosine b. And there it is, check mark. Put a little happy face, and we're good. How do you feel, guys? All right, so we have a handout. I think you can probably knock all of them out without much assistance, but if you need help, let me know. You can work on them as a group. And if the last one gives you trouble, let me know, and we'll do question 6 together. All right, that's it, guys. See if you can turn them in today. We are done.